Here we are at 9b from our target 5. We're asked to go ahead and solve for x in this case. We do notice that we have an and statement because we have the 3 parts to this one. So that is an and statement, and so we should see a graph where we have 2 circles. And it doesn't really matter right now if they're open or closed, but they should be going towards each other. Okay. Now, as we go ahead and look at this one, we're going to try to isolate the variable with the x in the middle. So we want x all by himself in the middle. And how we do that is we have this 4 right here that really has nothing to do with x, so we'll subtract that from all 3 sides. Now when we do that, we end up with -5 minus 4, that comes out to be -9, is less than or equal to. In the middle, the 4's end up canceling out with one another, leaving us -3x, which is less than or equal to 0 minus 4 comes out to be -4. Next, what we'll go ahead and do is divide both sides by -3. I'm sorry, all 3 sides by -3. And when we do that, we end up with -9 divided by -3, well, that comes out to be +3, is less than or equal to, the 3's in the middle end up canceling out with one another, leaving us with just the x, which is less than or equal to, negative divided by a negative comes out to be a positive number, and then we have 4 divided by 3, so 4/3, or 1 1/3. Now, in just thinking about this, what is a number that is smaller than 3, I'm sorry, bigger than 3, I should say, so a number that's bigger than 3, but less than 1 1/3. Well, unfortunately, that doesn't actually exist, but the reason why that doesn't exist is because when we did this operation right here, we divided by a negative on all 3 sides, which means then we have to flip our signs. So we can't forget to flip the signs if we multiply or divide by those negatives. So now we have our correct inequality, and now we can go ahead and graph it. So this is our number line. Then we have 0 over here. We have 4/3, which is a little bit bigger than 0, and then 3. Now, in looking at the inequalities, we notice that they do have the little bar underneath, which signifies that they can actually be those values. So we have that closed circle around each one. And then just like normal, we test a number. Let's go ahead and test maybe, in this case, we'll test like 2. So is 3 larger than or equal to 2? Yes, that's true. Is 2 larger than or equal to 4/3? Absolutely. So because 2 lies in between, it was true, then we know we're going to be shading in between this stuff. You could test 0. In fact, well, let's go ahead and test 0 and see what happens. If we were to test 0, like we normally do, is 3 larger than or equal to 0? It absolutely is. But is 0 larger than or equal to 4/3 or 1 1/3? Unfortunately, it is not. And as a result, it does not work for both, so that means that this region is false. If you were to test a number bigger than 3, it would come out to be false. And again, it has to work for both. All right. As a result, that is our final shaded region. Now moving on to, lastly, the interval notation. For our interval notation, we'll go over here. The smallest thing that x can be is 4/3. And since we can be 4/3, we have a little bracket around them. And then x is going along until it finally reaches 3. And since it can also be 3, we have a bracket around 3. So there is our interval notation. Again, though, that is 9b from our Chapter 5 targets.